Okay, welcome back, guys. So this is the most important part of linear programming. Okay, so till now we have seen how to plot basic graphs. Basic graphs means x greater than 0, x less than 0, all small regions, right? Y less than equals to -3, y less than equals to -100, all those regions we have seen how to plot those graphs. Second lecture we already saw how to plot lines which are in inequality format. For example, y plus 2x is greater than equals to -5, y plus 5x is less than equals to 100. Okay, all those regions we have seen and how to mark these regions. So also now we saw that, okay, when we are plotting one or two of the plots in over here, so that might give you a bounded region or an unbounded region. So what do we mean specifically by unbounded region and bounded region? If the region which is marked by the inequality, if that is going on forever, so that is known as an bounded region, unbounded region, right? But if the inequality is bounded within a point, right? If there are, like, for example, 3 points within which a triangle, for example, so that is a bounded area, right, which you can imagine, so that is known as a bounded region, right? So which is specified within some limits, so that is known as a bounded zone. So how will we get a bounded zone, and what are the regions, what is the maximization point, how will we maximize a function which is given to you, will be all looking into this lecture of ours. Okay, so let us look into this problem. So there is a problem given to you that there is an objective function. So basically, what is an objective function? Maybe a problem statement. Okay, so there is a function, okay, so which you have to, so they are saying that maximize. So there can be two types of questions, right? So either you have to maximize or you have to minimize. So what do we mean by maximization? That if you have a function which is given to you, which is a variable, like which is dependent on x and y, so it is the interdependent on two variables, right? So what is our option now? That using this x and y, we have to maximize the value of z. So that is our option. Okay, so we have to find out x and y, those values of x and y for which z is maximum. So what is our main focus? To find out that point for which z is maximum. And second option, they will be saying that, okay, what is the value of z? Okay, how will we do that? Once we get this x and y point, we'll just plot or put the values into this equation and we'll find out the value of z. Okay, for that maximization or minimization, we'll be getting the value. Okay, what is the maximization and minimization value and at which point it occurs. Okay, anyways, so let us go into it slowly. Okay, so let us first try. So these are all the plots that they have given you. So these are the four regions that they have specified that you have to mark, and out of this you have to find out if there is a zone, and if there is a specified zone, if it is bounded or not. That is the first question. If it is a bounded zone or an unbounded zone. See, understand, if it is an unbounded zone, for instance, if I'm saying that, okay, you have a line like this and this is an unbounded zone over here, right? So you can clearly understand that it can have a minimum value, because why? Because it is increasing now. After this it is increasing, so all it will keep on increasing after this. So it will always have a minimum value but never a maximum value. Okay, similarly, if I have a graph something like this and I say that, okay, this is my zone. Okay, maybe specifically, like, the graph is saying that, okay, y is less than equals to minus x plus 10. Okay, for instance, so this is a graph for this and this is the zone. It is because it is less than equals to, right? So now what will be my understanding? That, okay, so this function is reducing its value thereafter. After this value, after this point 10, it is keeping on reducing. So clearly this function will have a maximum value, because after this maximum it is keeping on reducing. There is no point where it can increase after this. I hope it is very clear. Okay, because it is going down right after this. So this is known as maximum value and minimum value over here. Okay, so those are the values. So if I'm saying that, okay, if I'm marking a month from 1, 2, 3, 4, so January, February, March, so what will be the maximum month? 12th. So how do you know? Because this is a bounded zone. You know, it is from 1 to 12. After 12, it is again coming back to 1. So that is why you have bounded yourself. That is why you can clearly say that, okay, 12 is my limit, right? Now, if I'm talking about a year, for example, it is 1996, 1997, 98, 99. It will keep on. Can you see the 23? It is currently 23, 24, 25. It will keep on going, right? So there is no upper bound, right? But for example, understand, if, for instance, me, I am born in 1996. Okay, so 1996 is where I started my journey. So this is a minimum value which I have specified, right? So you understand. So what is the minimum value? And I am unbounded, okay? Why? Because I can keep on going forever, or I can die in the age of 26. So it doesn't matter. But for now, there is no limit over here. So that is why it is unbounded, right? So you understand the concept of boundedness and unboundedness? Okay. So let us go into our main topic. So let us go into x greater than 0, y greater than 0. So we'll take one graph at a time. We'll draw 4 graphs for all the 4 regions that they have given. Then we'll take it up in a 5th graph, plot everything together and try to mark the zones. Okay. So x greater than 0, as we have already seen, x greater than 0. That means first, what is the point? We'll take x equals to 0. X equals to 0 is nothing but the y-axis. So x is greater than 0 is this zone. All points over here is x greater than 0. I hope you understand. So what is x greater than 0? So this is x greater than equals to 0. So this is the zone. Okay, first graph is done. Number 1 plot, which is number 1. See, everything is marked. Number 1, number 1. Number 1 is done. Okay, so now we are going into the second plot, which is telling you that, okay, y is greater than equals to 0. So what will be y greater than equals to 0? Can you understand that y greater than equals to 0 will give you a straight line of y equals to 0? Forget the inequality, okay, for now. So y equals to 0 will be nothing but the x-axis. Now they are asking you about y greater than equals to 0. So all these regions will be y greater than equals to 0. I hope you understand. Okay, so the y greater than, so we have plotted the first graph and the second graph over here, 1 and 2. So y, x greater than 0, x less than 0, x greater than 0, x less than 0, y greater than 0, y less than 0. So we have plotted 2 graphs. Now understand, if we combined 1 and 2 graphs together, so can you see that which is the common zone? So can you see that the first quadrant will be the common zone? Because in this, we have second quadrant and first quadrant. Here we have first quadrant and fourth quadrant. So which is the common zone? 1. So clearly from this, we can say that, okay, this is my region of interest. Okay. So from these 2 graphs, we have not plotted the third and fourth graph, but from the first 2 graphs, we can conclude that, okay, this is my point of interest. Okay. So can you see that we are moving towards something called a boundedness? Okay. We are trying to find out which zone we are interested to study about. Okay. See, there is like when you try to choose after doing class 10th or 12th, you have options. Okay. Let me go into computer science. Let me go into political science. Let me go into history. Let me go into arts. Let me go into anthropology, biology, whatever it is, right? So these are your point of studies. Now, can you see that, okay, I have studied physics, I have studied chemistry, I have studied physics, I have studied maths. I did not like chemistry and maths, let me choose physics. So this is what exactly you are doing. So you have chosen, like from 1 and 2 graph, you have chosen like this part of your study. So from 1 and 2, this is my conclusion that, okay, we will be studying about this graph. Okay, so next we'll be looking into x plus y less than equals to 60. Okay. So let us look into x plus y. So x plus y less than equals to 60. So what is our first thing that we'll do? X plus y equals to 60. Let us plot this graph. Okay, just random plotting. Okay, I am not interested about the points at this point of time. I am just trying to plot it. Okay, so y equals to minus x plus 60. So can you see that 60 is the y-intercept over here and minus x. So it will be looking something like this, right? And it is, so can you see that, okay, y is this. So now there is a less than equals to, y is less than equals to minus 60. So which one will be a zone? It will be everything which is inside this region. Okay, can you see, this was my plot for x plus y is less than equals to 60. Equals to means this line will also be included. Okay, understandable. Now understand, okay, but the previous question, in the previous, this is plot number 3. But in plot number 1 and 2, we got this zone over here. So this was my point of study, only the first quadrant. Can you see that over here, we have included something from the first quadrant, from the second quadrant, from the third quadrant, from the fourth quadrant. So we are not interested about these quadrants because we have already chosen only the first quadrant. So we'll be now looking into the first quadrant. Okay. So let us also mark with the straight lines the first quadrant. So now combining 1, 2 and 3, which one will be my point of study? So can you see that? Okay, let me bound our line only till this much because this is my point of study till now. All the outer ones are cancelled. We don't want to understand what is happening over here, but this is what my condition and study is all about, right? I hope you understand. Okay, so now let us try to mark these points. Okay, so this point over here will be by this line. So this line itself, only this line. So x plus y is equals to 60. So can you see that for this line, so this is nothing but the y-axis. So y-axis will have an x coordinate of 0. So this will be x as 6. So this will be 0, 60. Right? Now, if we are looking into this one, so can you see that, okay, this is the x-axis. If there is a point on the x-axis, y will be 0. So clearly mark 0 over here. So if you put y equals to 0 over here, x will be 60. So this is 60 comma 0. I hope you got the 2 points. Okay. This is the conclusion after plotting 1, 2 and 3 graphs. Okay, now 3 are over, so that means 90% of my work is over. We are only left with the fourth plot. Okay, so how much time did it take? These two are anyways like we already know, so this is like pre-planned before our exams. We should be knowing these two graphs. Okay, this is a new one. Plotting this will not take hardly 30 seconds. Okay, not more than that, because we already know how to find out the values of x, find out the values of y and plot the graphs. Okay, we already know.